My name is Mark Attard, and I'm co-founder of Earthcore SIPS. We're located in Lafayette, and what we make, or our overall general idea is that we make highly energy efficient building envelopes or materials for that. SIPS, or structural insulated panels, are one of the products that we make, and we make several other products that that fall in line with that, like insulated header material, insulated studs, and a few other variations of that. But the basic general idea and the basic purpose of it is to create energy efficiency in homes, whether those be existing homes or new homes. For those of you who don't know, a structural insulated panel essentially is a replacement for typical stick frame construction. So you eliminate your 2x4s and you replace it with foam, essentially. And this
so it's structural.
Yes. So this is,
it's load bearing.
Yeah, this is an example or a cross section. You guys can take a look at it. It's really simple. It's what it is basically a sandwich of polyurethane foam with two skins on the outside. And the general principle of it, in terms of how it can function structurally, is the same thing as if you were looked at an I-joist. So you would consider the OSB, in this instance for the skin, as the flange, and the foam as the webbing. Those working in concert actually are a stronger material for building a house than stick frame. So the basics of SIPS are energy efficiency, but there's two different types of SIPS that you should know about. The kind that we make, which is polyurethane foam, and then the second type, which uses polystyrene, which is a foam that, your coffee cup is made out of. The reason why we use this is because we feel that it's a better, stronger, and more energy efficient component than polystyrene. It has less permeability to water. It cannot be melted. It cannot be burned with chemicals. You can take a torch to it, and until it reaches about 650 degrees, it's not going to do anything except for smolder. So in that respect, we actually are getting some orders from the 4 Mile Fire people, because this is a replacement that could actually withstand a fire in the future. With the OSB on it, less so, but we have another skin material that we use, and we can use almost anything on the exterior here as long as it has some structural capacity. But another popular one that we use is magnesium oxide, which comes in sheets, looks very much like drywall, but it has the added benefit of being fireproof, as well as resistant to moisture, and it won't grow any mold or mildew. So we get a lot of clients. In fact, we're finishing up shipping an entire house that we built from foundation all the way to roof out of SIPS with MGO on it, because they have the added benefit that the MGO on the inside is a finished material, so they don't have to do anything once it's up except for tape and mud the seams like you would normal drywall. And then on the exterior, it's a really good base for brick or stone or stucco, whatever you want to use. So without getting too terribly technical, the idea or the reason why this is so energy efficient is, if you look very closely at it, you'll see a lot of little air pockets in it. And what happens is that this is a two-part foam. So it gets mixed in as a liquid, and then it cures like this. it has what's called a blowing agent in it, which has heavier gases than air and oxygen, and these little pockets of air trap those gases in it, which creates a very high R value in a very minimal amount of space. So this is cut out of a 4-inch panel, and this is equivalent to an R value of about 20. I'm trying to think what our core is, but it's around 25, 26, an R value on here, and we will make a panel as thin as 2.5 inches all the way up to 12 inches. So we have R values that stretch almost to 100 per inch, or 100 for the whole thing. But this is the basic R value per inch is 7 on this, which just to give you a comparison, if you're looking at just typical fiberglass bat insulation, a cavity, a 2x4 cavity that has fiberglass bat, in theory, has about an R13, but it's not really as effective as all that, because the other advantage for SIPS that over other forms of insulation is air infiltration. The more air infiltration that you have in things like fiberglass insulation, cellulose insulation, the less effective your R value is for that wall. So even though the house with all the studs in it has a fiberglass bat in it that's rated at an R13, with compression of that fiberglass bat, with air infiltrating from the outside or lost from the inside, your effective R value is reduced. And I would say that the typical house, like in Martin Acres, you probably have an equivalent R value of about 2 when it's all said and done, if you're lucky. So how this is the other advantages is that you're losing, because this is structural, you're losing a lot of that a lot of those studs. There's a green aspect to that just simply by the fact that you're not using as many trees to build the same wall. But the other advantage of that is that every stud, there's a connection from the outside to the inside, and that's called a thermal bridge. And so every time you have that stud, you reduce your R value in that wall from, let's say, optimally in that fiberglass bat wall you're getting an R13, you're reducing your R value to approximately 0.5 R per inch. So on a 3.5 inch stud, you're only looking like at about an R1.5. Once you add all that up, including your headers and your trimmers and everything that goes into building a wall, you're looking at a loss of 25 to 30% of energy just through those wood members in the wall. By eliminating that, by decreasing the amount of air infiltration that occurs in a typical framed home, a SIP home can reduce energy consumption by up to 70% in a SIP home built from the ground up, roof, walls, everything.
So you do, all of the walls in it? I mean, and then just how do you what's the construction, and how do you run the electrical, and like what is that?
Well, before we go there,
okay.
Do we want to? Are you ready for a Q&A, or do you want to keep going and wrap up? And
we can. I would. The only thing else that I would say is that particularly here in Boulder and in Boulder County, you're looking at a lot of retrofits, and a lot of people don't think of SIPS in terms of retrofits, but it's very adaptable. In fact, how I came to this meeting was through a customer of ours that did a pop top, and they did an addition off the back, and we used SIPS for that, and we used SIPS for the top. Now, it doesn't remedy the existing walls that you keep, but it does make more energy efficient the whole house as a whole. The other thing is that with Boulder, the City of Boulder Green Regs and the Boulder County building codes, it's much easier to reach those goals that they've set and those requirements that they've set by using an insulated building envelope like this, as opposed to trying to mitigate the thermal bridging that you have with stick construction, doing spray foam insulation, and then doing some sort of thermal break on the outside by using rigid foam insulation. So this is simpler, and the other advantage of it is that it comes in a panel that's 4 feet wide up to 24 feet long. So then you've panelized your house so it's easier to put it together. So instead of taking, I mean, as an exaggeration, taking a day to build a wall, this would probably take you, you know, a 20-foot wall, you're talking about 5 panels, it'd probably take you all of about 20 minutes to put it up. And a typical house, let's say a 2,500 square foot house, the walls will go up in about a day. And the roof would probably be about another day, day and a half. So you cut down on your construction time, you cut down on waste, there isn't all this wood waste. There's many advantages beyond just the energy efficiency of it, but what we focus on is that energy efficiency, since that's very prominent, not only here in Boulder, but just nationally. So.
How long has your company been around?
We've been around since 2009. We started off as one of the co-founders and I, Scott Anderson, and I, we started off basically brokering a deal with a company out of state to manufacture a panel to our specifications. We quickly found a lot of disadvantages to that, and we started manufacturing our own. And in developing that manufacturing process, we developed several different new products as well as new methods for making the SIPS that, that all are have patents filed on them right now. So we have, as a company, we're fairly unique in that we're pushing the envelope of where we think SIPs have been and where we think they should go, as well as developing new technology to advance them. Yeah.
You mentioned, is it 600 degrees before they burn or melt?
Yes.
So a house fire gets considerably hotter than that. So
sure.
It
depends.
Okay, so let's say your house is on fire.
Amazing.
It's
Yeah.
like 2,000 degrees or something. The toxic gases, is this thing going to give off, a family sleeping in a burning house with SIPs in it, are they more likely to not wake up? I mean, what's the downside of the fumes of polystyrene or polyurethane foam?
Okay, well, so getting into that, first of all, in terms of the meltability of this, you have to remember that if this gets put up, there's drywall put on this, which is a fire barrier, and then there's something put on the side of this, which is also a fire barrier. So in order for it to actually burn to the point where it starts to get to this, it's already over 600 degrees. Yeah, and people are, and there's incineration going on at
right.
that point. So now, in terms, so it's not going to get to the point where it's going to be releasing any gases that people would be in danger of. I mean, if they were in the house, they would be dead from other things, I guess is what I'm getting at.
By the time that's off-gassing, they're
right.
gone.
And the testing on the off-gassing isn't anything more or less toxic than in a typical home that's built out of stick frame. If you burn lumber that's been processed, there's a certain amount of toxicity in there, and these don't have any more toxicity than that. Now there's other things in the house that do form that, and the combination of everything is dangerous, no question about it. Now, in comparison to polystyrene has to be treated with, and has been treated with a fire retardant, because, and even at that, polystyrene will soften at about 120 degrees, and at about 160, 170, it'll just melt. Mm-hmm. In fact, I know of a house up in Wyoming where the engineers specified SIPs and they used polystyrene SIPs. They had a very high-priced roofing material that they were putting on. They didn't want to put it on they were getting towards the winter. They didn't want to put it on until the spring, and so they covered the roof. And by doing that, they created a greenhouse effect, and they melted all the foam out of the SIPS and had to replace like 40 or 50% of the roof.
Oh man!
And it was styrene. Now, getting back to that retardant that they put in the styrene is carcinogenic, and it's been not here in the States, but in Europe, it has now been eliminated from building processes. So, in Europe, polyurethane is about 90% of the SIPS market, and styrene's about 10%, and now it will be none. In the States, it's the flip. And the reason why is typically because of the capital investment it takes to bring the equipment in order to make the panels. But we got around that, like I said, by inventing some processes that don't quite cost quite as much.
So how I'll throw in one. How familiar are architects and contractors with using the material? And because how are the walls attached? Do you get the plans and build the material and ship it ready to assemble, or are you shipping 4x8 panels and they're kind of attaching them together? How does it work?
The answer is kind of all of the above. So, the timber frame industry uses SIPS a lot, and the reason why is because they can take the 4x8 panel and basically just screw it to the timber frame, and they don't have to worry about structure or anything, and they just...
What is timber frame, like log homes, you mean?
No, a timber frame is, they'll take a timber, a log, form a timber out of it, and the whole entire structure is put up. It's like a pole barn, essentially.
Okay.
And then you skin the outside of it, and that outside doesn't really require any structure to it.
So they're not getting any structural benefit from it.
Right, they're just getting the insulated,
insulated,
and it's easy to put up, so
right.
and it's quick to put up.
Right.
So, by all of the above, I mean, we will sell the blank panel, the 4x8 blank panel, the 4x24 blank panel, and people who are experienced with SIPS, they'll take it, they'll cut it up, and they'll put it together however they want to put it together. The typical process, though, is we'll get a set of plans, we'll create a set of shop drawings, just like you would if you were getting a specialized window or door, and those shop drawings will have details of how they go together. Once those shop drawings are signed off on, we'll go into production. We'll take panels that we've already poured off the shelf. We'll cut them up. We'll put the window openings in. We'll put the headers in where they need to be, and then we'll put in our spline connections. And we have 2 or 3 different types of spline connections.
That's where the walls make 90 degree
Right.
angles.
So you have a 4x8 panel, and basically you can think of it. You have a groove on one side. It's like wood flooring. You have a groove on one side, and you have a tongue on another. And it slides right in, and you nail them up, and you go to the next one, it slides right in, and you nail it up. So the typical process is that we make that. We cut all those angles for the roof and cut all the windows in and all the doors, and we assemble them, pre-assemble them to make sure that they fit, and we have all the right measurements, put them on a truck and ship them out to you, and you stand them up. And depending if you're doing an addition or you're doing a retrofit of some type, we'll provide connections, details of how to connect them to existing construction and things of that nature.
I'll say if I was building new, I'd definitely use SIPS, hands down. It's interesting that you bring up the remodels, and I'm glad you do. It's something worth considering when they are appropriate. You say you do roofs as well?
Oh yeah, we do roofs, we do foundations, we do floors.
Great. Did you say this was open cell or closed cell? Or
this is closed cell.
Okay.
Yeah,
so much more resistant to water.
Oh yeah. It is a vapor barrier. There is no other required vapor barrier if you're going to use our panels.
Great. What is the for your manufacturing process? What is the waste factor in what you have? Are you blowing this foam right to the edges and there is no waste, or are you having to blow out and then cut it off?
There's no, in terms of the foam, there's very minimal waste. How the process basically works is that it's injection molding essentially, and we have equipment that dials that in based on the volume of that particular panel, where ultimately we get like a little bit of a mushroom of foam that gets knocked off the panel, and that's it. So waste in terms of foam is very, very minimal. Now when we start to fabricate and cut things up, there is some waste there, but we reuse a lot of it. We either reuse it in another house if it's a large enough piece, or we'll cut it up for samples, or we'll find some other use for it. We don't very often. In fact, I think we have one dumpster for our foam and one dumpster for our wood waste, and I think it's been at least 3 or 4 months since we changed them out.
Nice.
So I mean, yeah, it's pretty minimal.
So SIPs have been around a while, even though they kind of haven't been mainstream.
Yeah, absolutely.
I don't know if it's long enough that recycling them has come up too often because they're still in the houses that were put in. But what's the recycling procedure for polyurethane or polystyrene panels?
Well, first of all, by building a house with a SIP, with the air infiltration properties, the insulated properties, and the vapor resistant properties, it should be well over 100-year home when you build it. So you're right in the sense that they have been around for 100 years, so we're not getting to the point of tearing them down. We're looking for sources or ways to recycle the foam. The wood and the foam together do not recycle, because they'll recycle the wood, but they don't like the foam.
Right.
And so we're looking into options as a company for that, but we're also looking into developing our own foams that are a little bit more organic. I mean, there's no question about it. I mean, the foam is still it's still it's an oil-based product.
Right.
There's no question. And now it still has a very low global warming potential to it, and it still has a very low greenhouse gas emissions potential. In fact, really, ozone depleting potential is almost zero with the type of foam that we use. So recycling is a bit of an issue. You can't really. I guess if you were careful, you could take them apart and you could reuse them, but that would be a lot of work.
That's what I was thinking. So I would like to think that once they go up, people are happy with their house for 100 years. But we've seen in real estate time and time again, someone with more money buys the house and wants to just make it different. There's nothing wrong with it. It hasn't, expired its life. It just, they want something different. So if they're taking down a wall to make a room bigger, that's what I was kind of thinking. Could they reuse it? But I guess it's a tough call.
Yeah, I mean, I guess there's that potential, but I would say it's pretty unlikely. Now, that kind of brings up another aspect of is just like, well, once the wall's there, it's a SIP wall. Can we really add on to it or modify it? And the answer is yes. We have a couple of different ways. You had asked a question about electrical. So what we do is we drill a chase for electrical. So part of that shop drawing process is we'll get the electrical plan, and then we will put those chases in exactly where that electrical is going to go.
Chase is like a conduit in the foam?
Well, not a conduit, but just
on the inside of the wall?
A chase way. So it's basically we just take a drill bit and we just drill a hole into the foam, and then if if that's right here, then all the electrician does is he cuts a hole into the skin here, and then he can pull wire right through that hole through here, and then he puts a remodel box on, and he's good to go. We've had plenty of cases where people changed. I mean, of all the things that people change their mind on, once architectural plans have been developed, it's electrical. And so it's it's not a difficult thing to take and move a switch from here to here. We have developed some procedures for doing that. Now the other thing that we are developing is a grid system that we would put on the inside of the panel so that you wouldn't even touch the foam at all. You could run all the electrical, and for that matter, you could run plumbing on the outside wall at that point. And then in the future, if you wanted to move something, it would be very easy to tap into that.
That would introduce a lot of air, right? So your R value would go down.
No. What I'm saying is on the inside is so you'd still have this, and then we'd have a grid system that would be attached to on the inside of the wall, and then you wouldn't be touching this foam at all. In fact, it would be preferable because unless you're experienced with SIPS, you're going to have a tendency to do something to that foam that you're probably not going to want, like drill a hole all the way through, which then of course is letting air in that you don't want in. And I've seen many electricians do.
So can you just go patch it with good stuff?
You can. You can. In fact, when we send out the panels, we send out depending on what the skin is, we send out either a sealant, which is an adhesive caulk, or we send out a SIP tape for all the seams that just it's exactly what it is. It's tape. It's 4 inches long. It just goes along the seam, and it ensures that there's no air coming in through that seam. But the other thing we send out is great stuff.
Great stuff.
And you squirt that in before you put the panel together, and then it squeezes out, and it ensures that there's no air getting in at that seam.
So we can keep going.
Big concern for a lot of folks is the formaldehyde content, both for the polyurethane as well as for the OSB glues.
Yeah, there isn't any.
There isn't? Wow.
No.
Are you having to use special OSB, or is that just the way the state of the...
No, the OSB really has no added urea formaldehyde. I mean, everything in the world has formaldehyde in it. It's just a matter of whether it's added, if there's added urea formaldehyde, and OSB does not. And the foam never has.
That's great.
So.
I have a question about cost.
Yes.
So, compared to your traditional
Stick
frame drywall kind of deal, what is the kind of the cost difference?
And then what's that energy savings where that would be?
Right. How long would it
Yeah,
take to
we
get that back?
assume it's more expensive. So what's your break even?
Well, you assume wrong. And
sold.
and I'll tell you why. 2009 new code requires a thermal break in certain climate zones. Requires a thermal break on the outside of a new construction home, and even if you're doing an addition, you have to do the same thing, which means that you have to put 1 to 2 inches of rigid foam insulation on the outside of a stick constructed home. Now, if you're going to do that, and you add that labor cost in, you add the material cost in, and then you're going to do, let's say, like just a cellulose insulation, we are slightly under that cost on a per square foot basis. Now, the reason why we've gotten it to that point is because we're talking with the Meritages, the KB Homes, and the Del Webbs of the world to provide them panels, because what they've been doing spray foam, and they're running into this problem with the code that now they have to do this, and then they have to do a vapor barrier because the spray foam that they're using is open cell and it doesn't have the vapor resistance that they need. And when we sit down and we cost that out to them, it is cheaper for them to do this than it is for them to meet the code as it is. In 2012, will be an even greater addition to energy efficiency for building envelopes. Right now, from 2006 to 2009, it's about a 15% increase in energy efficiency for building envelope. And from 2000, by the time we get to 2015, it'll be a 50% jump from the 2006 code to the 2015 code. So that just gives you an idea of where the code is going and what the requirements are going to be. And really by 2012, it's going to be nearly impossible to build stick frame with any sort of this typical pricing structure that we've seen in the past. And that's why that's where we positioned ourselves in the market. And then when we're talking about a more custom home, as opposed to something we're going to build with KB that's going to be a repetition of the same design, it's very competitive, and it just kind of depends on the design of the home, but it's still very competitive.
Cool.
So let me ask the last question, and this is the how's it made question, really. Okay. So what ingredients are you guys mixing together to make the foam, and how's the manufacturing? What does it look like? How do you actually make the? How are these panels made?
He'd tell you, but he'd have to kill you.
Well, some of that's true, because we, like I said, we have several patents filed on some of our processes. But the basic idea is that it goes. We take our skins, we put them into a press, so a two-sided press, and there's a form that goes in between to hold the space open, and then through that form are some holes, and we take and we pour the technical term is pour the foam in to that space. Now it creates a tremendous amount of pressure. Trying to remember what it is per square foot.
The foam curing creates the pressure.
What's that?
The curing of the foam is creating the pressure, or the press?
Right. Well, it's a chemical reaction, right? It's an AB chemical reaction, and so it's creating a tremendous amount of heat, and it's creating a tremendous amount of pressure. That's why it has to be in a press. That's also why it's traditionally been very expensive, particularly polyurethane. Traditionally, polystyrene's been considerably less expensive than polyurethane, which is one of the reasons why we have such an advantage, because we're actually priced less in some instances in polystyrene. Mm-hmm. So it goes into that press, and that press holds it together while it's curing. And it, depending on the thickness, like this is a we call it a 4.5 inch. It's really a little bit less than that, outside to outside thickness. That takes about 45 minutes to an hour to cure. Our 8-inch, 9-inch, 10-inch panels can take up to 2 to 3 hours to cure. So, that's it.
Okay. Sounds like you need a lot of space for your business.
We have 30,000 square feet.
That's kind of what I was thinking. Yeah.
So, do you pour a foundation underneath this and then build on top of it, or what's the?
A good example: a house in Minnesota. We built foundation panels using the MGO.
Like the 8-inch.
The 8-inch.
Right.
They're 8 1/4 inch outside to outside. We use the magnesium oxide because it has it's more of a water resistant.
Yeah.
They put those in, backfilled it, rolled their first floor, put up a set of panels, rolled their second floor, put up a set of panels.
Rolled? What do you mean?
Just laid out their first floor and
that's interesting. So
put the sheeting on.
So yeah, that's interesting. So you can have exposure to moisture. I mean, is there a time? There must be a degradation factor or something. No.
Well, when you're dealing with OSB will suck up a lot of moisture.
Right. Well, you wouldn't use that for for your stuff.
But so you wouldn't use it for the foundation.
Yeah.
And even when you're using it for your walls, we have very specific instructions as to protect them from the weather, particularly before they're installed. Once they're installed, it's a little bit less. It's a little bit less of a problem. But before they're installed, we have all these edges, and if they swell, then it becomes more difficult for the panels to go together. The MGO, you don't have that problem. The MGO, you could set it in water for a year, and it's not going to deteriorate. But the OSB, you definitely would have an issue.
All right. Well, Mark, you've definitely educated us on the product and the company and what you guys are doing. It sounds fascinating, and I want to thank you for coming and presenting to us. We learned a lot. Oh,
Yeah,
how do people reach you?
Well, like I said, we're located in Lafayette, South 120th Street, just north of South Bowler Road in Lafayette, and our 800 number is 888-299-3049.
And your website is EarthcoreSips.
EarthcoreSips.com.
All right, excellent. Thank you.